Hi everybody, this is a video for Math 105. It's a problem from the textbook in section 1.2 and it's problem 44. And the first part of the problem, or part A, is to determine what values of x must be excluded in this equation. So if I'm trying to solve this rational equation, and again, it's rational because some of the denominators have variables amount. Okay, so how do I determine what values must be excluded? Well, it's a consequence of us not being able to divide by 0. So I'm looking for when are the denominators 0. So I've got denominators of 2x, 3x, and 3. Both 2x and 3x are 0 when x is 0. So for A, part A here, x cannot equal 0. So we have to exclude the value of 0. Okay, so now part B is to solve it. So in order to solve it, the first step that most people take when you're doing it by pencil and paper is to find the common denominators and then multiply both sides of the equation by the common denominator. Then reduce it. Once you reduce that, you'll be left with a linear equation. So the first step is basically to take your rational equation, eliminate the denominators by multiplying both sides by the common denominator, and then producing a linear equation. Okay, so common denominator. I've got 2x, 3x, and 3. So the common denominator of 2x, 3x, and 3, well, you've got to have the x, and you've got to have factors of 2 and 3. 2 times 3 is 6. So it's 6x. So I need to multiply each term on each side by that common denominator of 6x. Okay, and I've done the same thing to both sides. I've multiplied both sides of this equation by 6x. So that's why it's equivalent. And the reason I want the common denominator is because now all three denominators can be reduced, can be canceled off. So in this case, so if I'm now reducing the 6x and the 2, the x's cancel off, and the 6 is 2 times 3, so the 2 cancels off, so I'm left with 7 times 3. And this one here, the x's cancels off. Here, the 2 times 3, 3 cancels, so I'm left with 5 times 2. And here, the x does not cancel, but the 6 being 2 times 3, the 3 cancels, so I'm left with 22 times 2x. Double check that. Here, canceled off the x and a factor of 2. Here, canceled off the x and here I canceled off a factor of 2. Here I cancel off a factor of 3, leaving 2. And here I cancel off a factor of 3, leaving 2x. Okay, just simplifying this, I get 21 minus 10 equals 44x. So notice this, I've got my linear equation. So I've gone from a rational equation to a linear equation that's equivalent to it. Equivalent as long as x is not 0. Okay, well now you just solve this. 21 minus 10 is 11 equals 44x. Divide both sides by 44. And you get x equals 11 over 44, which is 1 over 4. Don't let it bother you the fact that the x is on the right side, right? Equals is symmetric. You can rewrite it x equals 1/4 if you want. Okay, keep in mind, for MyMathLab, they write it as a solution set. So they put it in curly brackets. That really only matters if there's more than one solution. Here there's just one solution. So it's the curly brackets, seem a little bit, I don't know, unnecessary. Okay, so this means that if I plug 1/4 into this equation here, both sides are equal. So let's do the check. Oh, first check, can I use 1/4? Yes, because the only value I have to exclude is 0. So I can use 1/4. So this is okay. Second check, and this is just kind of to make sure we did the arithmetic correct, is let's plug in 1/4. Let's evaluate. At x equal 1/4, and just check. So if I do 7/2 times 1/4 minus 5/3 times 1/4, if I evaluate this left-hand side for x equals 1/4, I should get 22/3. Well, let's see. This is, I got complex fractions, which I'm going to try to not let me get confused. So this is 2/4, and this is 5/3/4. Now each of these, think about dividing by a fraction as multiplying by the reciprocal. So that would be 7 times 4/2 minus 5 times 4/3. Okay, and now that's 28/2 minus 20/3. Okay, well 28/2 is just 14. So that's 14 minus 20/3. Well, I need a common denominator. What is 14 times 3? 14 times 3 is 30 plus 4 times 3, 42, right? 42 thirds, that's 14, minus 20 thirds, and that's just 42 minus 20/3, 22 thirds. Does that match? Yes, matches. Yay, we're happy. So all of this extra sort of work is just me verifying that this thing I found really works. In some sense, it's sort of checking my algebra here. Now, this required a lot of fractions, so it's good practice for arithmetic doing fractions. But sometimes you'll mess this up, right? So this is only as good as your arithmetic. So, watch out for that. Anyways, to recap, we've got a rational equation. We solved it by using a strategy that turns it into a linear equation and then solving a linear equation. Now, because it's an irrational equation, we need to think about what values we have to exclude. And that's, in this case, just checking for which values would cause you to divide by 0. Can't do that. Okay.